Hi guys, welcome to another episode of MrLopezClasses.com. This is our course of marine air conditioning systems. And this is the chapter 8. Today we are going to talk about the pump relay system. This is a magic design to avoid too much raw water pumps for different air conditioning equipment. In this design, they condensate the system in one raw water pump, big one, to supply water for different compressors, for different condensers. This is a magic design, it's commonly used, and with this design you improve the performance of your boat. To understand the pump relay, we are going to refresh our previous split unit diagram. In this diagram, if you check in this area, we have the suction of salt water. The salt water enters over there, and the salt water goes out here. In other words, to install a split unit like this, I need to make a through hole and install the valve, the strainer, the raw water pump per each equipment. I want to install one split unit like this, or a self-contained unit. You need to make a through hole, install the through hole, the a.c.r, the valve, everything per each air conditioning equipment. But what happens if I have a big boat with 6 or 7 air conditioning equipment? I need to make 6 holes on the bottom of the boat. It's a good idea, make 6 holes additionally to the holes of the engines, and additionally to the hole of the generators, and additionally to the holes for the water makers, and additionally for the holes of the gyro. Is good idea? Probably no. In that case, it's good idea a C chest. It's a central box with only one through hole, and I connect everything over there. This is one idea, the C chest. Other good idea when I have air conditioning equipment is install a pump relay system. What is the idea? Is only one raw water pump for 3, 4, 5 compressors. Only one through hole, only one pump. Of course, after that I install a manifold, and I supply water for 2 condensers, 3, 4, 5, depending of the boat. The name of that system is the pump relay system. What is the meaning of that? It's like this. This is the picture that I prepared for you. This is the picture of the pump relay system. Look at this. I have only one pump. What is the secret? I am going to replace, for example, in this video, I have 3 compressors. 3 compressors, and of course I have 3 evaporators. I have 3 compressors, and I need supply water, raw water, to cool the refrigerant in those 3 compressors, to condensate. Okay. I need install 3 through holes and 3 raw water pumps. That's not good. What happens if you install only one pump? Okay, with the capacity in gallons per minute or gallons per hour for those 3 pumps, for those 3 compressors working at the same time. That's the most important. That the pump that I am going to install right now should have the capacity to supply enough amount of water for those 3 compressors. Alright, I install the pump with good capacity in gallons per minute and pressure. I select the pump in the catalog, you know the procedure, and right now I have the raw water pump. This is the pump, and okay, the raw water enter over there, circulate through the strainer, and after that I have raw water here. I have raw water here in that suction manifold. And now, suppose that I only want to start one air conditioning equipment. The first one, the first compressor, this one. I want to start this one. Okay, I go to the thermostat for that equipment. The thermostat number 1. That's the thermostat number 1. Now, I select the temperature that I wanted, and immediately that thermostat is connected with the board. You remember the board, the computer, for that condenser. for that unit, and that unit, this is the board, the circuit board, is connected directly with the circuit board. This is the circuit board. This is the circuit board of the pump relay. That's the pump relay. Pump relay. That's the circuit board of the pump relay. In this particular case, the circuit board of the pump relay receives signals from three evaporators, from three thermostats. The thermostat number 1, number 2, and number 3. And that pump relay sends the signal to activate the central pump neutral and hot line, send the signal to activate the central pump depending which thermostat is activated. Okay, in this particular case, I am going to activate the thermostat number 1, and the thermostat sends the signal to the computer, and the computer sends the signal to the circuit board of the pump relay. The pump relay activates the pump. Right now the pump is running, and at the same time send the signal, the purple signal, to open that solenoid valve. This is a solenoid valve. And the solenoid valve open, and that compressor receives raw water, and the coil of that compressor is cooled. Oh, I want to start other air conditioning equipment. The second one, the number 2. Okay, the number 2, I select in the thermostat the temperature that I wanted. Immediately that thermostat sends the signal to the board of that equipment, and the board sends the signal to the pump relay, and the pump relay activates the pump and activate the solenoid valve, and I have water for the second one. Or with the third one, I have the 3 at the same time, the 3 equipments working at the same time. Yeah, this is possible because the pump have the capacity to supply water for those 3 compressors. This is a wonderful picture. This is a wonderful system. We are going to repeat what equipments are involved in that design. The only that I need to introduce is the new raw water pump, the big one, with the capacity for the 3 equipments at the same time. That raw water pump is coming with that central box. The central box have a PC board, and the PC board receives signal from the thermostat, from the computer of each evaporator, and additionally send signal to activate the pump, and send signal to open the solenoid valves per each compressor. If the solenoid valve of the second compressor is closed, it's because the air conditioner number 2 is off. It's because only 2 compressors, 2 air conditioning equipments are working, the number 1 and the number 3. In other words, with only 1 air conditioning equipment running, the raw water pump, big one, is running. And the supply manifold, this is the supply manifold. We are going to put the supply manifold in red color. That supply manifold is pressurized with water, and the water enters in each compressor only if the solenoid valve of that compressor is open. If the solenoid valve is closed, I don't have flow of water in that compressor because that compressor is off, that air condition is off. Yeah, that system allows that all the equipment, all the air conditioners work at the same time with only 1 pump, or only 1, or only 2, or only 3, depend of the design. Yes, my friend, you can buy those. This is the typical control box for those equipments, and yes, you can connect. I know maximum 5 equipments, but probably there are more, or you can order. For example, Dometic, they fabricate the control box for 3, for 4, for 5 equipments. It's simple. The installation is plug and play. It's too simple, and this is the advantage. This is the advantage. You can connect, for example, in this case, 1, 2, 3 with at the same time. One important thing is this. You need 2 manifolds. 1 manifold for suction, and one manifold for discharge. You can discharge all all of the output of the compressors in one manifold, and you discharge in that manifold. You can buy manifolds fabricated in a nickel copper, or you can fabricate those manifolds in PVC like this. This is a manifold fabricated in PVC pipes, and you connect. This is the manifold for in this particular case for 1, 2, and 3 compressors, and you have the solenoid valve per each equipment at the input of the equipment. Yes, when you connect that manifold, you have exactly the connection in the this is the manifold. This is the manifold in PVC that you fabricate, and those are the solenoid valves that you want to install. The purple, the green, and the pink. Those 3 solenoid valves. Those are exactly the same like this. Exactly the same like this. 3 solenoid valves. This is fabricated in PVC. With the solenoid valves, depending of the solenoid control valve, is in 12 volt DC or 24 volt DC or in AC. Yeah, depending of the design of the control box of the pump relay system. Yes, Dometic have a pump relay system for 2, 3, 4 compressors with the activation of the solenoid valves in 12 volts or DC or in AC power. Both of them. That depends on your design, but there are solenoid valves that open and close with the AC or DC. The solenoid valves work like this. The solenoids can be used in other type of application like this. This is a solenoid. When the solenoid is powered, positive and negative, immediately the plunger closes the valve. This is a solenoid valve to control the movement of the fluid. What type of fluid? Water, gasoline, diesel, gas, alcohol, any type of fluid. The fluid can be controlled. The fluid enter here and continue over there. You see the shape of that valve. Okay, when the plunger is off, the valve is open and the fluid pass. When you activate the coil, the window close and the fluid no pass. This is a typical solenoid valve or shut-off valve. Where you found this type of valve in a boat? The shut-off valve for fuels in the output of the fuel tanks, or the shut-off valve at the entrance of the fuel injection pump to avoid that the fuel enter in the fuel injection pump and the engine stop, or the idle in the idle solenoid on the carburetors to control the idle and to control that the engine start and stop. There are other applications in hydraulic system. In air conditioning system, we use solenoid valves. In an air conditioning system, the solenoid valve used to reverse the cycle from heating to cooling or cooling to heating. It's a solenoid valve, 3-way valves that control the flow of the refrigerant to the evaporator or to the compressor, heating or cooling. There are other applications that we are going to study in our class of auxiliary systems or hydraulic systems, and also in our class of air conditioning. This is a good example of the solenoid valve used for different applications. The solenoid valve used in the pump relay system in order to allow that the raw water enter and continue into the coil of the condenser according with the activation of the solenoid. The solenoid receives the signal here, and the solenoid open and close depending on the signal, and the raw water pass from here and continue into the condenser. Okay, this is a great design. This is a wonderful design. Or you can buy the manifolds fabricated in nickel copper, like professional manifolds for supply and discharge. Normally, the supply manifolds have the valves in red color and the return manifolds in blue colors. We are going to use in our design one discharge manifold, the red one, and the black one on top, and the supply manifold, the red one in the bottom. the discharge manifold could be with the blue valves. But this is only nomenclature of colors. But you can design one manifold for input of raw water into the coils and other manifold for the output of raw water from the coils. And at the end of the day, the picture is like this. Yeah, you have a input manifolds in the bottom and output manifolds. Yeah, this is a typical system with a pump relay system. Yeah, like this, exactly like this. You have manifold in the bottom to supply water for the coils of the condensers, and the top ones are the discharge manifolds. Exactly the same like the picture that I prepared for you. This is a wonderful equipment. We are going to refresh. This is the thermostat of the air conditioner number 1. This is the board, the computer of the air conditioner number 1. And that board receives the signal from the thermostat and sends other signal to the pump relay. And the pump relay sends signal for the pump and sends signal to open the valve in order to allow that the raw water circulate in that specific compressor. This is a great design to avoid too much through holes, eliminate that possibility, and install only one pump with the capacity, inflow, and PSI for all the equipments, and supply water, raw water, to the manifold and keep the manifold pressurized all the time. The raw water pass to each compressor only if the solenoid valve is open. This is a wonderful design to improve the performance of the boat, eliminating more holes in the bottom of the hull.